Here at Lake Superior State University, senior engineering students must complete a capstone project to wrap up their undergraduate education. Engineering students Christopher Bohm, Daniel Henderson, Katherine Mendrick, Noah Murray, and Raul Velasco Garcia are the members that make up Team BAM. They were tasked with developing an autonomous system for bathymetric mapping and underwater sound source localization using an uncrewed surface vehicle, the Blue Boat.
LSSU's Club Amore was the sponsor of this senior project. The club specializes in autonomous marine robotics, which they use to compete in maritime robotics competitions and to support local ecological research projects. The purpose of Team BAM's project is to support both of these areas with an acoustic localization system for the maritime competitions and a bathymetric mapping system to support the ecological research. The advisor of this project was Dr. Hildebrand, and the project contacts were Dr. Sarda, Chase Jannetta, and Zach Kasuba.
The Blue Boat contains an onboard computer and GPS to navigate itself along a path set by the user using a control algorithm in ROS. The onboard acoustic localization system is used to locate an underwater sound source, called a pinger, and relay that information to the user and the Blue Boat's guidance algorithm. The Blue Boat will either approach or avoid the pinger once the pinger's location is known. The bathymetric mapping system measures the underwater terrain using sonar as the Blue Boat moves through the water.
We used current control to plan the Blue Boat's routes because it had a satellite image overlay of the area that was to be mapped. This helped out when planning how to effectively and efficiently map bodies of water. The path was uploaded into the boat system, which followed a given path, but would adjust the path if it detected a pinger.
The Blue Boat is equipped with hydrophones, which are basically underwater microphones, and they listen to the water for the noise of the pinger. The algorithm then takes the signals from all three hydrophones and compares them to each other. To get more technical, since the hydrophones are in different known locations, the sound wave caused by the pinger will hit each one at a different time. We then calculate an angle from each hydrophone and get an intersection point as a guess for the location of the pinger. A custom circuit was made to both amplify the signal and also act as a low-pass filter for the system. The low-pass filter works like a sound filter for any source emitting a frequency between 1 and 40 kilohertz, which is the range that the pinger operates in.
As the Blue Boat executes its path, the sonar collects high-resolution bathymetric data. The acquired bathymetric data is then processed using a custom MATLAB script for 2D or 3D maps with position overlays. Alternatively, ArcGIS Pro can be used to overlay bathymetric data onto satellite imagery.
Since we're based in Sault Ste. Marie, Michigan, we had to plan our testing around the seasons. That meant simulating and designing everything we possibly could during the off-season. The obstacle detection and path planning system developed by Team BAM will be put to the test by Team Amore during their maritime robotics competitions. This same system could also be used to locate objects underwater, like airplane black boxes for search and rescue. Beyond competitions, this system has potential in environmental monitoring, marine research, and various industrial applications.